Alrighty, it looks like she's begun. Do the usual test and such. See if it plays properly, audio and such. Do the usual test and such. Alright, we have succeeded in making a video. Alright, so a couple of outstanding points. Just to keep re-emphasizing. I mean, you can just say this stuff and then people won't argue the exact things you're exactly saying. And then start arguing other things and implying you said stuff you didn't say, and just very difficult to communicate with people. It really shouldn't be. It's not that complicated. But anyway, I find these very good quotable quotes, these first two statements. This one, this one should be enduring. In the micro universe, measurement is an act of violence. Because somebody posted a comment, the guy who's arguing in these vague terms, to some stupid Swedish experiment where they photographed electrons. Can't do that. I mean, it's just impossible. And yet they pretend they accomplished the task, and they haven't. It's theoretically impossible. So it's not even worth having a conversation about, because it can't happen. But anyway, the other good point is the only fields are fields of force. So, yeah, there's no electric field, magnetic field, blah, 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 unless there's something making it. Now, the only field that's kind of universal is gravity. And as I've obviously pointed out, the only other field of force is really magnetism, which is gravity filtered. And that's all you really have. There's nothing else. There's no other source of energy except for what we see as like photons, radiations of those kind of forms, bits of stuff. But there's no fields. It's just, there's force. All right. So I guess we'll read the comments. I will try to make sense of it. It's not going to be easy. So this is the Master Pool guy. He left a very long comment, completely off the subject. Very likable guy. He takes care of his cats and likes the animals and all that kind of stuff. So, I mean, I mean, he's been posting comments on my Amendum channel for years and all that kind of stuff. And sometimes I just find him a little too wrong, but whatever. I just, people just make statements and I'm supposed to, say, yo, yes, that's the way it is. No, that's not the way it is. So I think I did this monopole crap. Yes, this crap. Yeah, so we're all done with that. So here's the John Gray guy again. Another, I don't know what your point is. So he says, do you know this picture? What do you think about it? So first off, let's play the video. I mean, it's just garbage. It doesn't say anything. It certainly doesn't contradict anything I've said about the movement of electrons. Like if you were to imagine how electrons move, I pointed out that they would tend to wobble through space, that they would tend to do that because they're constantly exchanging. They're constantly losing their velocity as they're being accelerated. That's why they can't hold a permanent velocity, is because the field is neutralizing their velocity constantly. And in that process of neutralizing it, they're exchanging forward momentum for left, right, up, down momentum. So they would tend to wobble in space. It's exactly how I've described them. And so I don't know why he's posting this. But this is garbage. Even though this looks exactly like what I would say electrons would look like, I would call it junk science. It's garbage. It's not evidence of anything because it's theoretically impossible to do this stupid thing.
Swedish researchers have released the first clear video ever taken of an electron.
All right, so clear video of an electron. I mean, it's obviously not a video of an electron. It's just an insane statement on its face. is impossible. So I don't even, this doesn't say anything. It's beyond the 600,000 views for this junk science. There's no statement about whether this has been peer reviewed or whether anybody has done anything with this other than say, what the fuck is it?
Riding on a light wave. Scientists used a device called...
Yeah, they don't ride on light waves, whatever that is, right? They're pushed by energy, photons. They're pushed. They don't ride.
The quantum stroboscope to freeze the electron.
So the quantum stroboscope, the magical quantum stroboscope, another wormhole bullshit, phantasmagorical, talking caterpillar. Just more crap. All right, scientists in Sweden they didn't film anything. Subatomic particle, no, they didn't. The electron, for the first time, no, they didn't. An electron is approximately 1,867 times smaller than a proton. So what? It's, you can only see it with photons. And photons, as I just pointed out, violently interfere with electrons. Violently. That's the whole way your whole economy runs, on the fact that photons violently interact with electrons. You can't bounce them off of electrons passively. Can't be done. And it is constantly moving. Just garbage science. Has to be garbage. Oh, comments are disabled. Isn't that? Yes. Coward, 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 coward. So I don't know. Like I said, I don't know what this is, where it came from. So it's not unsourced rubbish.
Electrons motion at different stages, just as you would freeze a hummingbird's wings in flight using a regular stroboscope. The resulting video has been slowed down and looped to show the motion clearly.
Yes, regardless, to show nothing. This is absolutely a non-real thing. There's no video camera that can see that small. So what is that? That doesn't even make any sense. How can you see something so small as an electron? Oh, that's right, you can't. Rubbish, just absolute rubbish. And you just imagine, like I said, just measuring an electron by seeing how it affects a magnetic field by its motion. Like if the electron moves this way, it would affect the field, but the field is also going to affect it back. So it's going to push the electron. It's inevitable that all your videotaping is your own attempt to videotape the electron. That would all you would see is the energy you use to try to see. You would never see the actual thing. You would just see you trying to see it. It's like a blind person having a blind stick, and all you're going to see is the stick. You're not going to see what he's seeing or trying to see. You're just going to see his stick. Look at the blind man's stick. Look at the way the blind man's stick moves.
MSNBC.com. I'm Alan Boyle.
So this was an NBC. They actually posted this on NBC. Amazing. This piece of steaming crap. I just mean, anybody who knows anything about physics has got to know there's no small thing that you can bounce off of electrons. You cannot see them. It's impossible to see them. Oh, Christ. I shouldn't have to tell the physics this. So what is your point? So again, even if that picture was somehow accurate, which it isn't, electrons go like this when they move. Now, how is that inconsistent with my theory? Oh, yeah, that's right. Not at all. So anyway. All right. I mean, I really shouldn't have to. I mean, I was thinking, okay, well, maybe I should do a video on detailing how photons work and how we see things based on bouncing tiny things off of giant things. That's how I see this. I don't see it. It doesn't send energy to me. Photons bounce off of it and then bounce into my eye. So little tiny things hit it and resolve its position, its color, all the details I see. And then we can maybe bounce electrons off of this, like an electron microscope, and If I can coat it with metal, make it charged, then I can bounce the electrons off, and they'll bounce a certain height off the metal. And then we can see the resolution of that. We can take images in stages, and we can see the how much reflection popped up at what height, right? I mean, the high things are going to make the electrons bounce high. The low things, the electron doesn't bounce as high, you know, all that kind of stuff. And we can resolve an image that way. So that makes sense. Tiny electrons, you know, hitting something more above the big thing by comparison to the size of the electron. But what do you throw at an electron? There's nothing to throw at an electron. There's no force you can affect it with that doesn't affect it dramatically. It reacts dramatically, not minorly, but dramatically. That's why you can push electrons, is because they dramatically react. I shouldn't have to explain this. There's no mechanism to measure electrons without violently measuring. Killing it with the ruler. Totally crushing it with the ruler. So the master pool guy posted this whole long pile of crap that he stole from some other place, and for a reason I cannot possibly understand. Why did he post all this crap? So you know, he could post a link to this web page and say, this is something I somehow have to explain, or this is something to do with the subject. I don't know. I don't see how it's related to anything I'm talking about. I don't see where I've ever made an assertion on the point he's trying to make here, which I don't even know what the point is. So I'll deal with it just because it's got physics in it. And so I can point out how it's junk. But that's the best I can do for you. But I don't know, what's your point? Could you, before you make a comment or post shit, could you actually make a point about what you're refuting? Or what you think this refutes? Or what point this makes? Or how this is relevant? Because I can't see how it is. All right, so he says magnetic forces can't be blocked by any material. So where did I say magnetism is blocked by any material? I can't remember any video where I said anything about being able to create a shield, a magnetic shield, and as I pointed directly out, magnetism is gravity. It is. It's gravity just filtered, just reshaped a little tiny bit. You know, tiny bit. Okay, it's just like separating some dual fabric material, and I just separate the two kinds of threads again. I certainly haven't changed it fundamentally. I've just taken the nylon and the cotton and separated them. Nothing dramatic. So again, what video have I implied that you can block gravity? I just don't understand what this means. What's the point of this? You can obviously absorb these things. Tiny bits of the force you absorb, and it's a fact that you move because you absorb them. You're occupying the force. The force came in, you're using it temporarily, and therefore it doesn't go where it would have gone, and so it can't affect the things it would have affected. Again, the people on the opposite side of the earth are moving towards the center of the earth, and by doing that moving, they're using some force up, and that force doesn't hit me. Okay, so that's why I end up going down, is because they've used up some force, and then when I use up the force, hey, that ironically makes them move towards the earth, because now I've used up force that's not going to hit them. That's what I've asserted. What exactly, where does this crap mean anything? Okay, this is what my question was leading to. What was your question leading to? Magnetic forces can't be blocked by any material. Gravity can't be blocked by any material. Same thing as, that's exactly the same thing. As I've pointed out, that gravity is exactly what magnetism is made out of. There's no magnetism if there's no gravity. Magnetism is just a form of gravity. I've stated that overtly, over and over and over again. So your statement is, gravity can't be blocked by any material. Yes. Where have I said anything different? This is what my question was leading to. I don't know what that means. Sorry, I barged into your classroom. I don't know. You know, it's sort of a shit statement. I mean, this really isn't a classroom. The whole intention is to have conversation with people who have some argument to make, some capacity to say something relevant. It's not a classroom. I'm not here to preach. I'm here to acknowledge arguments and refute them. All right. If you were my neighbor, we could throw baseballs at each other with mitts on. Okay, that's sort of irrelevant, but yes. Here is the situation explained below. I briefly, cursorily went over this, but I don't see any situation. So, all right. So I don't like this post just because it implies these are my quotes, and they're not quotes from me at all. They're quotes from some document he cut and pasted into here. All right. So it says in quotes, is there any material that can block a magnetic force? You can't block any force except to counter it with another force. Matter bits react to force. If something is staying still, it's because there's just as much force hitting here as there is force hitting here. That's why, relatively speaking. There's just as much. The imbalance between this thing and me and the earth and this table, they all have exactly the same imbalance if there's an imbalance. Yes, we're moving through the cosmos at a certain speed. So maybe we're all getting hit by more force on one side than we are the other side. But I'm just saying relative to each other, it's all balanced. So again, nowhere have I implied you can block magnetism, but the trick with magnets is that you can change them. So if I have two magnets and I bring them together, they're going to start affecting each other. And this magnet's going to kind of bend all the little atoms in this magnet. And this magnet will bend all the little atoms in this magnet. So the shape of the field will change, and it will become less magnetic out here because the two poles will start pointing towards each other. So you can bend a magnetic field by introducing another magnet or a ferrous material or a moving paramagnetic material. You can distort the field by creating more filtered force that affects the magnet. All right. Specifically, does lead block magnetic fields? Asked by Dustin. Okay, completely stupid question, simple answer. No. Yeah, it's just stupid. Anyway, magnetic fields, forces are caused by magnetic fields. Well, that makes sense. Forces are caused by magnetic fields. Amazing. So it's exactly, got it backwards. Force is what the field is made out of. It's a force. Field. Anyway, forces are caused by magnetic fields. It's amazing and stupid. Cannot be blocked. No. That is, there's no such thing as a magnetic insulator or a gravity insulator, to make it clear. Force, there's only, again, that's all the forces there really are. There's just gravity. And you can filter it and call it magnetism, but it's just filtered gravity. And that's all there are. There's not. Light is, you know, it's just the force, you know, at a frequency. So I guess you say, okay, that's another version. But you could essentially call that magnetism at a frequency. Anyway. A major reason for this has to do with one of Maxwell's equations. Bullshit. The equation has absolutely nothing to do with the reason. The reason is because the force can only be counteracted. That is, you can only apply another force. You can't undo the rocket on the space shuttle, except to put another rocket going the opposite way. A force is a force, of course, of course. Maybe that should be written down as a quote. And you can't undo a force, of course. Yeah. Yes, we could write the song. All right. Del dot B equals 0. Well, whatever bullshit that is. Which implies that there is no magnetic monopoles, which is just ludicrous. That is, see, they smash the atoms so close together that they say they're so close that we can just say there's zero space between them. They just say it, even though it's obviously idiotic, because clearly the little atoms are creating the magnet. So it's just stupid. I mean, on its face, a stupid statement. That is, whereas you can separate electric monopoles, there are no electric monopoles. There's only charge, and charge ends up producing magnets. Electricity is the movement of electrons in atoms. That's all it is. It's the movement of pressure inside an atom. It has absolutely, absolutely nothing to do with this subject in a sense. All right. That is where you can separate electric monopoles, positive and negative charges. So again, positive and negative charges, the electron and the proton, they're the thing creating magnetism. I mean, proton end, electron end, proton end, electron end. You stack those on top of each other, it makes a magnet. Jeez, I mean, I shouldn't have to explain this. All right, anyway. Such that the E field, whatever, I guess that's the electric field, never has to terminate on the opposite charge. Never has to terminate on the opposite charge. This doesn't mean anything. I mean, I've already explained how the force bounces perpendicularly, and that's why it always ends up going out the other end. I mean, I could give you another drawing of that so you'd understand that the force is just coming in mixed, it leaves segregated. That's the only phenomenon taking place when it comes to charge, okay? And that when you say a substance is charged, okay, that's different, because to charge it, you bent the atoms, you distorted their position. So it's not, you know, position is magnetism, pressure is electricity. They're two different things. The position of the electron and the proton, all right, is different than the pressure between the electrons. Okay, such that the E field never has to terminate on the opposite charge. You cannot do this with magnetic poles. Never has to terminate. Again, it's just not that complicated. You separate the poles, the electron and the proton, and as soon as you arrange a bunch of those, you've got a magnet. It's just that simple. There do not exist any magnetic monopoles. So he says it's twice, which is just hilarious. Clearly, the electron is the magnetic monopole. Clearly, the proton is the magnetic monopole of plus and minus. There, the north and south side of the magnet, clearly. This is just garbage. There is no such thing as magnetic charge. So amazing. When that's the thing that exists. The thing that doesn't exist is electric polarity. When all it is more or less pressure. There's no polarity. There's just an atom with pressurized electrons, or a substance, a surface, or a surface with unpressurized atoms. That's it. Electrons under pressure, electrons lacking pressure. That's it. That's all there is. All right, all magnetic field lines. So again, talking about the field lines without talking about the actual force is idiotic, because the field lines are abstract. They are not reality. The field lines are only telling you how much the rays of force are diverging. So when they draw the line is a representation that the width of the divergence is equal all this way around. At all these points, I can draw this circle around a magnet or something. All of that line, the separation of the rays of force emanating is the same. It's a topographical map. The lines are arbitrarily placed and just indicate that every piece of dirt at this location is the same altitude. It doesn't define the altitude. It's just describing the circumstance, but it's not really telling you the slope or it's not telling you anything. They're not real things. They're descriptions of things that are real. All right. All magnet fields must terminate. Okay, we did that. Because of this, there's no way to stop them. Okay, let me read that. There's no such thing as magnetic charge. Just an idiotic statement. All magnetic field lines must terminate on the opposite pole. Again, there's no there's no magnetism moving out of one end and going into the other end. There's no termination. That's like saying all topographical maps must terminate their lines, you know, the centric lines. Of course they all terminate. Doesn't mean anything. Okay, because of this, there's no way to stop them. That's just even silly. What does that have to do with the rays that are at the actual force? The actual force is rays. That's what's creating the inverse square law. This is what's creating the inverse, the rays separating. That's what's creating the inverse square law. The rays separating in 2 dimensions. All right. Nature must find a way to return the magnetic field lines back to the opposite pole. None of that ever happens. It's just such crap. Okay, magnets are not a flow of electricity. It just isn't. All right. However, magnetic fields can be rerouted around objects. That doesn't happen. This is a form of magnetic shielding. So now he's getting to the part that you can change the field by changing the atoms, change the magnet. So if you change how all the little magnets are lined up this way, and you introduce a new magnetic force, and now they line up this way. So you can change the magnet, but you can't change the force. All right. By surrounding an object with a material which can conduct magnetic flux better than the materials around it. So it has nothing to do with conducting the flux. So when you bring another magnet in, you're not conducting the magnetism. You're perverting the magnet. So you're changing the field because now you're bending the magnet towards you, essentially. So even though the magnet's looking like it stayed still, like it's pointed this way, the atoms aren't standing still. The atoms are bending towards the magnetic field and therefore changing the orientation of the magnetic field and changing where the field is the strongest. So now if you have something over here, it will feel less. So when I bring a magnet in here, or iron, I bring it in here and say something was magnetized here, this magnetism gets weaker because this magnet now, okay, is affecting this magnet. Jesus, not complicated. All right, the magnetic field will tend to flow along this material to avoid the objects inside. I mean, it's just, none of this avoiding happens, just complete rubbish. Nothing like this happens. This allows the field lines to terminate on the opposite poles. Just more nonsense. But just gives them a different route to follow. So again, no, it just substantially changes the orientation of the the magnetic flux, if we're going to use that silly word. Okay. You might want to check out, well, this was on that paper, I assume. I don't really want to check that out, which does a good job to answer your question directly. Well, I'm sure it doesn't. Okay, because it's got lead and copper. Obviously, paramagnetic materials would also induce a magnetic field in themselves, and therefore they would affect another magnet. So as soon as you are any form of a magnet, you will affect the other magnets in your neighborhood. All right, as seen there, lead has permeability of 1. This means that it is no better of a magnetic shield than air. Most of the paramagnetic materials are so close to 1 that it almost doesn't matter. So that doesn't really mean much. So the short answers, no material can block a magnetic field. Lead most definitely has little or no effect on a magnetic field. Right, you'd be better off with copper or some other thing to have some kind of hope, but obviously iron would be the best because, you know, it's ferromagnetic. But again, it won't be blocking the magnetic field. It will bend the magnetic field. In a sense, it will distort the magnet. It will affect the magnet. It will change how the magnet filters gravity, but it can't undo gravity. All right, if you want to block out magnetic force, your best bet is to reroute magnetic field lines. So again, you can't reroute them. Just nonsense. I mean, you're not rerouting them. You're changing the magnet's orientation. So, of course, the field lines change as you turn the atoms. The magnetic force will be in a different direction, the strong force. Shit. Around the object that is sensitive to those lines. The only thing that's sensitive is something paramagnetic or ferromagnetic, so let's not play any games. Do this by shielding the object in a material with a much higher magnetic permeability and surrounding material. So again, you're just putting something with more magnetism and just saying, look, I got a material that gets magnetic. It's like, look, you could take a heavy object and you have a little light object. The heavy object is going to be, you know, if it's iron, it's going to become more magnetic. So it's going to obviously have more effect on this. Say if I have a magnet here and there's two competing things to play with the magnet. This heavy thing is going to become much more magnetic, which means it's going to bend those atoms a lot more than the little thing. So obviously the orientation of the magnet is going to, instead of being north-south this way, it's going to be north-south this way. Shit. Not complicated. All right. Answer by Ted Fablik. Yeah, asshole. Electrical engineer, undergrad student. Oh, great. Not even a professional. All right, it is an interesting observation that while there are many analogies between electricity and magnetism, there really isn't an equivalent of a magnetic insulator. Well, that's because the two things, again, are fundamentally different. Like I said, electricity travels through conductors. It has to travel through atoms. It's not a force. There's no electric field. If there was an electric field, electricity could go anywhere. It wouldn't need the atoms. All right, the lightning bolts could go straight to Earth. They wouldn't have to fry all of those atoms along the way. You wouldn't even see the lightning. The lightning would be invisible if there was an electric field it could travel through. Oh, damn, there's no electric field. Electric doesn't produce a force. The electron and the proton are the things filtering force. And when they filter it, they create magnetism and charge. Oh, Jesus. People asking dopey questions. When will time travel be possible? Oh, fucking A. Not on the subject, newsflash. All right, anyway, it is an interesting observation. Okay, There really isn't an equivalent to a magnetic. However, engineers, being a clever bunch, oh yeah, sure, have figured out how to get around this problem. Oh no, they haven't. In order to shield, for example, an electronic device from external magnetic fields, no, you can't do that. But anyway, engineers will often use a shield or case that comprised of a material with a very high magnetic permeability. So a magnet, okay. That is a material that will allow a lot of magnetic flux lines within it. You're just saying a piece of steel, effectively concentrating the lines inside the material and then channeling them away from the delicate electronics inside. So they're just making the point that if you make the thing magnetic and you have another magnet, okay, but I still think you're still going to have a hard time putting another magnet in that case, I don't think is going to undo the effect. But you know, I mean, it's I'm just trying to think. So here you have ferro material as a shield for something behind it. Yes, okay, so that could sort of work where you're saying this magnetic field is very strong, and so it would go all the way down here if you let it. So if you put this magnet in this ferro material here, it becomes magnetic and repels this magnet. See, when this becomes magnetic, it's not going to repel because it's going to be exactly the opposite to this magnet. Well, the point is that both of them will tend to bend towards each other, and so the magnetic field, it's still going to get you in trouble because you're going to be plus minus plus minus, and so you're still going to have the little atoms are still going to be pointing down. So I don't see how that could work. Well, anyway, we'll get into an argument about it. That is the material that will allow a lot of magnetic flux lines within it, effectively concentrating the lines inside the material. It doesn't matter where the magnetism is in the material. Distance helps, but you'd have to have an undense ferromagnetic material. So you'd have to use one of those ferrous composites to reduce the amount of magnetism created. Anyway, and then channeling them away from the delicate electronics. Well, at least they put the word channeling in quotes because it is kind of a silly, you're not channeling anything. Looking at this from another perspective, sometimes it is necessary to ship magnetic components or materials via airplanes to their destination. There is no strict federal regulation regarding magnetic fields in aircraft instrumentation. A magnet on board must not interfere in any way with the flight controls for obvious reasons. So the magnets are usually packed head to tail to that their north poles are next to other south poles. Well, that would just make them stronger. And thin shields of steel or other non-iron based materials are packed around the magnets in order to shunt the field and to keep it from penetrating outside the box. No, they're just going to create enough distance where the magnet effect is neutralized. But I don't see how stacking the magnets north to south is going to make the magnets weaker. No. Lead is not, being a ferromagnetic material, cannot shield or shunt magnetic fields in this way. So at least they're using the word shunt. So they're pointing out that they're really just turning the fields. All right, answer by Hatch, PhD, CEO. Oh, CEO. Anyway, fine. I don't buy that you do much, that you do much, but separation is the biggest weapon, distance. So distance is your biggest weapon against magnetism. That's it. You've got to let it dissipate at the inverse square law. The rest of it is gimmicks that aren't going to be 100% effective. No chance. All right. Feel free to delete my comment or block me. I don't know, physics and astronomy. I don't know what that even means. Well, I will delete it because it's so far off subject. I mean, it's a specific subject. If we wanted to talk about compound magnetic fields, because that's really what this subject is, right? We're really talking about what happens when you compound a magnetic field. And it does have an effect. The field does change. When you introduce more things, more magnets into a field, you change them. Again, if I took a magnet and I'm affecting something here, and it's pulling a certain amount. So I'm dangling a piece of iron here. I have a magnet here, and it's pulling a certain amount of pressure. I can read it on a scale. It's pulling. And then I bring like paramagnetic material close. Nothing's going to happen. So I can put my hand close. Nothing's going to happen. Move my hand right in between. Nothing's going to happen because I'm not making a magnet. But as soon as I take material that can be a magnet, like the ferrous material, a strong enough magnet. Again, the point is now this new magnet I've made with this magnet causes this thing to become a magnet. And when this thing becomes a magnet, it affects this magnet and causes a change in the field. That's really not too complicated, right? All right, let's see what the comments say. When will time travel be possible? Yeah, it's just not going to happen. Time travel to the past would require a device that would have to rearrange the atomic structure of the universe to a pre-recorded state. Yeah. Well, I guess it just depends on whether you're talking about I mean, racing ahead of, yeah, getting to the past, this doesn't seem to be very realistic. I mean, you know, but getting to the future doesn't seem any realistic either. So, I mean, the past is gone, so you can't get there. It happened already, and it's gone. It doesn't exist. So obviously, traveling there would be ludicrous. The future, right, isn't gone, but it hasn't happened yet, so you can't get there yet either. I mean, you know, unless you freeze yourself. You have to freeze yourself, and then you can get to the future. But you have to like just hit a button that says, freeze me. And, you know, if you could instantly freeze yourself, instant freeze. And then you could have somebody else hit the unfreeze, instant unfreeze. Then you could be in the future. But you didn't really time travel. You just didn't live and waited to live until the future got here. You waited for it. Okay, time equals illusion. There's no illusion. Time is a real thing. It takes real time for photons to go from here to there. It takes real time for me to, you know, unzip my zipper and pull my wiener out and take a piss. These things take real time, a real amount of time. No, it's not an illusion. So never. There is only recreation and memory. Well, again, it's not how I would say it. All right, incorrect, Elvis. Time is the recorded state of matter. Well, where's it being recorded, retard? Oh, the magic holographic black hole or something? Yeah. Where's your projector? How are you going to get your film developed from the black hole? And then what projector are you going to run it through to see your recorded copy? And then how are you going to get into the film when it's just a videotape? How do I put myself into the videotape? Yeah, I couldn't do that. That's silly. It actually has a systematic measurement in physics. Well, sorry, Hex Rex, you're full of crap, app. Okay, what are your thoughts on thermodynamics? Well, I've talked about it. I mean, what do you want me to say? You know, yes, things are, as I pointed out, pressurized. The whole universe was, you know, full of pressurized things. and it took time and energy to pressurize them. And so I would argue over time, you're going to run out of energy for pressurizing because it's stuck inside the things you've pressurized, right? So then everything will start to fall apart because there won't be enough pressure on the outside because all the pressure's on the inside. And then when all the pressure on the inside starts leaking out, then there'll be a whole bunch of pressure on the outside and it'll push everything small again. So it just goes, just pressurized, unpressurized, pressurized, unpressurized. Anyway, find the way it is. I don't know what that means. What are your thoughts on thermodynamics? Find the way it is. Well, I mean, I guess if you're saying, do I think their theory is find the way it is? Obviously, they don't even understand what the energy is. So they have no clue what thermodynamics represents. That everything that has a velocity had to get it from somewhere. See, they just make up notions. They have black holes hurling through our space at half the speed of light. And you have to think to yourself for a minute, what do you mean? These are the heaviest things in the universe and something has pushed them to go half the speed of light? What rocket would it require? How much energy is required to push a black hole to a speed half the speed of light? I mean, it would be all the energy in the universe again. It's so paradoxical. So they have notions of energy in the universe that just can't make any sense. It just can't. How did all the atoms inside the black hole, how did they acquire their velocity at half the speed of light? How did that happen? Because that means that the black hole had to just catch stuff that was all going the same way it's going. So it was either going, it had to be going faster. So they had to catch, the black hole had to keep collecting things that were going faster than half the speed of light. Do you really think the universe is full of all these material bits that are going half the speed of light? I'd argue clearly not. So I'm just saying they don't know what thermodynamics is because they take no responsibility for the amount of heat that's actually in the known universe. All right, so let's see. So I did that, right? So that's it for the comment. So I think I've okay. So I did my job there. I just wish Master Pool Guy or anyone who's commenting, I mean, I just wish you'd be a little clear about when you're asserting I'm wrong. If you want to say, I mean, I don't really want you saying you're an idiot, but I mean, I want you to indicate where you think I made an assertion that requires you to tell me that this somehow means something, like somehow I haven't addressed the point. Because I just don't get the references. You're implying it. I'm just saying you're implying you're contradicting something, yet there's no reference to where I made any assertion inconsistent with. All right. Let's see. Incorrect Elvis times. Okay, we already did that. What are your thoughts? Okay, Hexrex. Here we go. I have a PhD from Berkeley. Well, yeah, that's Piro's school. I don't think you do anything called hard physics there, but whatever. Yeah. Take some pictures of an electron for me. While you sit alone in a bedroom full of 70s porn lights, I don't know. It's the frame rate is kind of low, but you want to think it's porn lights. It's your prerogative. It's actually a pretty interesting physics spiral. But go ahead, complain about things that couldn't possibly matter. And the hair. Okay, so again, it's just so funny because, like I said, I can't imagine if I go on like Einstein's Facebook page. Am I going to hear a bunch of people ragging about Einstein's hair? I mean, you're just such pussies. You can't make a real argument. Just fail arguments. I don't even know what a burnt Barbie doll means. Is that what you did as a kid, you little psycho? You burn up, you melt little Barbie dolls and pretend I could get back at those women because they keep laughing at my small penis? Is that what you were doing? Hmm? little Berkeley poofter. Little college for unicorn turd eaters. I would take you more serious if you didn't. Well, again, this worrying about what I look like. So again, I just pointed out how Einstein didn't look like anything, and that's what a smart person says. A smart person says, "What's the fucking difference in what I look like? Are you retarded?" I'm just saying. So that's how I win an argument with Einstein. Is I talk about how he didn't take a shower often enough. He looks like a douche. He's short, and let's see what else. I don't think it was that short actually, but I can't remember. Anyway, and what's the other thing he did that was just hilarious? Oh, he had a shitty voice, so I win the argument. Cool. Oh yeah, and you went to Berkeley to learn how to do that kind of logic, huh? Hmm? Oh yeah, I went to college to learn how to argue by ad hominem. Oh, you're so fucking brilliant. No, you're part of the idiocracy, Hexy Rexy. Okay, so he's just, I don't know. He says he has a physics degree. Obviously, he doesn't because he can't make a physics argument. He's talking now about the color of the green of my shirt. I mean, can you get any lamer? How small is your penis? Micro penis, no doubt. Double micro. Micro times infinity. Like you don't have one at all. Oh, cool. Yeah, just what we needed, some buzzing sounds. Oh, amazing. I have a PhD from Berkeley. Now I'm just going to make a bunch of idiotic comments about superficial nonsense to prove I'm an intellectual. I really wish it was legal to do like betting online where you could just bet in a video instantly and we could all do like a $2 wager, and then we could find out the truth. I mean, what are the odds that Hex Rex actually has a degree in physics, right? Versus preposterous liar. Bald midget, actually wanking to my hair, dreaming he had any. All right, so I'll post the little declarations once more. Again, I think a ton of physicists are going to wish they thought of this great quote. In the micro universe, measurement is an act of violence. I mean, that's just classic. That could be a Newton statement. Put your wife on stream. Now, well, I'm going to block you. As if I would be stupid enough ever to have a wife. What do you do? Why do you marry things? For what purpose? Yes, permanently single. Thank you. But anyway, fuck off. Not physics, retard. All right, so the only fields are fields of force. So the only fields are gravity and magnetism and light a little bit. You can have a field of light. Let's say electromagnetic radiation, but it's just magnetism at a frequency. It's actually just monopolytic magnetism at a frequency. It's just electron force at a frequency. So I did listen to the Franklin Who guy. So I might as well show his website. Is kind of, you know, crappy. But, you know, can't see some people's, you know, blah, 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 blah. Let's see, another irrelevant comment. Oh, retracted, damn. Anyway, let's see if I can find it. Magnet's wars between two parallel conductors now. Message, no. I know I opened it somewhere here. Magnetic force, no. So where the hell is he? Double slit, no, no, no. Carousel, no. This might be it. No. Oh, here he is. All right, so this is pretty poorly formatted, obviously. Yeah, unreadable text, blah, blah, blah. So it's a theory of everything. So anyway, in the NCPS thing or whatever, he was kind of arguing with, so they're having a conversation about ether with a guy who premises his theory based on the idea that they got this special knowledge of the ether from some translation of the Declaration of Independence. So it starts off that bad, and you're just saying, why are you having a conversation with a person who is mentally ill? I mean, obviously. There's, you know, it's just obvious. So, I mean, to have an hour-and-a-half conversation with somebody who thinks there's special knowledge hidden in the Declaration of Independence, I mean, that's a really scary, almost kind of psychotic. You know, that's like talking to dogs, frankly. That's pretty damn close to talking to dogs, is when you're reading physics into the Declaration of Independence. So anyway. And so he's arguing with this guy and saying, look, I agree with everything you're saying, which is hilarious in a way. But you have to call them you have to call the ether positrons and electrons, and then we can agree on everything. But the weird part is he's saying the ether is made of positrons and electrons. So that means like they're everywhere. And he's still relying on some notion of vibrations sent between them. That's what the ether is supposed to do, is do the vibrating part. So it just doesn't make any sense. How can the ether be made out of sand? And then you say, and the sand magically through ESP communicates with itself. That doesn't make any sense. You didn't solve the end. You didn't answer the question. So yeah, it just fails dismally. I mean, it's just relying on some kind of magic vibration force. No energy for this vibration and no mechanism to transfer it from one thing to another. No mechanism of communication. So it's just funny that he was criticizing this other guy for not having any material substance to his ether, and Franklin doesn't either. His ether needs an ether because his ether is made out of things that can't communicate force to each other without some medium. So it just wasn't, you know, it's just a non-answer. Fails. So, you know, let's see. Not for practical use. Sorry for taking up the char. I don't know what that is. Let's see. They had no idea what use their stuff would eventually be, but they enjoyed it. What is all this stuff? Oh, okay. Similar. Mushroom. You're a physicist. Oh, this is somehow this is the old chat. That's funny. Still up there. I didn't delete the old one. From the last room. Yeah, funny. Funny in a funny kind of way. All right. So no comments. So let's see if there's anything else. I mean, I could play some of the Franklin Who stuff, but I just don't know if it's worth it. I don't know if we'll get any, you know, I don't know if you'll have enough context to follow along. But let's go for it anyway. So let's just go back maybe here and play some of it.
Vibrational mechanism involved, which is the simple resonance and
yeah, but that doesn't explain why because if I have two vibrating things here, logically there is no reason for them to be attracted to the other vibrating. Just because you're saying that, I'm saying that you don't have any real reason for why that might happen.
Although if you look at quantum entanglement, there's no way to explain it to quantum physics. And this ether model that I have explains it very, very simply, very.
Yes, right. It's ether model from the Declaration of Independence. You know, explains entanglement. I don't even know why a rational person would even concede this concept in the first place, but whatever. And his assertion that quantum mechanics can't explain it, well, of course, nobody can explain it because it's superluminal.
Directly.
Well, I would say based on what you're saying that it doesn't, because that's really all you got. And quantum entanglement just means that I have this like red and white square, and then when I separate them, I go look at this white square and it's like the other square must be red.
Well, so he's not even really being fair to all these stupid double eraser experiments and all the contrived experiments to try to get around how it can't be right hand and left hand glove. So he's really pretending they haven't done all these experiments to try to gimmicks to try to avoid the consequences of right and left-handedness. But I agree with him that those experiments are shit if he wants to say that, because yes, they are shit. They really haven't proven that all this entanglement thing really is yes, if I find my right hand glove, I know the other glove's a left hand glove.
It's red, so that must be quantum entanglement. So if you talk quantum entanglement, that still doesn't tell me anything about why these two particles.
Let's see what we got here. Are you accomplished? So irrelevant. It's not a physics subject. Has nothing to do with anything. Or do you just do YouTube stream because you're lonely? So just a waste of time, nonsense, rubbish. I suppose you don't have a practical job in the field. Somehow that would make a difference. Einstein worked as a patent clerk. Again, you people just have no clue how actually history works, and how lots of people who had who just studied physics on their own, became very good at discovering and revealing and all that stuff. So you're just so pretentious and obnoxious with this nonsense argument. Oh, okay, you are a vindictive ass, angry at the world. None of this shit. I've proposed an argument. You seem to not be able to debunk it in any way, and you're completely off the subject. So doesn't that make you the asshole? I mean, what, do you go on religious sites and say, hey, stupid religious person, you got a wart on your head. Your God must not exist. Is that what you do? Is that the best argument you can make? You don't know what evolution is. You can't do any of that kind of stuff. Like, you can't act like a fucking goddamn fucking intellectual or somebody went to fucking high school. You can't even make a fucking high school argument. How's that burnt hair doing? What's this burnt thing? You're so envious. You're just so envious. So he's the same guy with no penis. Micro penis much? Yes. Penis invertus? Yes.
Should come together and form a unit. See. Now,
what are the ways that they
I'm going to give my example, how I explain that, because you see, once again, everything that you're saying is absolutely correct in that there is vibration. Vibrations are, in fact, very important.
Yeah, so no, they're not. So we got that wrong. Vibrations are almost completely irrelevant, except for the fact that electrons are sensitive to specific resonance to knock them out of their position. So yes, if you push them, they have a tipping point. But beyond that, vibrations are bullshit. Don't mean anything.
To why two particles should come together and attract. So this is my explanation, okay? So I just want you to have an open mind because I'm explaining to you basically what's underlying your theory, right?
Yeah, so Franklin is pretending that this wacky guy's whatever nutty ether theory from God stuff is somehow connected just because it has ether in it. It doesn't really connect in any other way. I mean, there's nothing else common about the two theories, so he's just trying to say, your theory is the same as mine. Listen, see, I'll show you. No, I don't see any connection between them, but go ahead.
And there's a vibration, and these vibrations cause things to attract, right?
Right. Another idiotic notion that vibration causes attraction. So again, they've just totally missed the charge has to be something a lot more substantial. Charge is powerful. Magnets are powerful. It's not about some dopey on phase, off phase vibration crap.
Not things, but elemental ether units. They're not things. They're elemental ether units, which are universally. They're
Elemental ether units. I mean, it just whoa, that just screams what?
Everything from the original element, everything is built up from our elemental ether units. They were the first things that appeared after the oscillation converted into an ether.
Yeah, the thing is that can be right, and you interpreted that right, but what you're interpreting wrongly is what those elemental ether particles are. You think they are something fundamental and different than the particles we can observe.
Well, they're
I'm saying that is logically is not going to work. But
Well, again, we can't observe, and that's a big problem. We have a real hard time observing any of these little tiny things. Again, maybe I should put observation in the phrase just to give it a little more pop. In the micro universe, measurement, or I guess observation, is an act of violence. So I could add observation. Make a note of that. Add observation. Measurement / observation. Yes, that'll improve it. Is an act of violence.
let me see if I can explain it, because, like I said, what you're saying about vibrations and attracting, that is absolutely correct. But you have no true explanation for how that works. But let me explain to you how I see that working, right? It goes along with what you're explaining, but it's actually much more physically possible.
So let's understand. In the physics, if you really go deep into the physics, he's just going to make a spring argument, a rubber band argument. So we're just back to something being, hey, look, it just keeps doing that. It can't just keep doing that. There has to be energy somewhere trapped or doing something that's causing this. This can't just come out of nowhere. If an atom moves through space, it just doesn't have, you can't just push it once and it keeps going. If that were true, then all the bits in the universe would be photons and they just keep going. It's just not the way it works.
Right? So this is the way I explain it. So the only thing that you have to change in your theory is to say that fundamental ether unit is either a positron or an electron, which I would represent by a red block positron, white block electron, okay? That's the only change you need to add to your little theory, okay? But the fundamental unit isn't.
Your little theory. He's not being patronizing at all, but he shouldn't even be talking to the psychotic.
Positron and electron. So the question is, why does the positron and the electron attract each other? So what I say is that each of these things have a resonant frequency. So when you hit it like a bell, it will ring out of frequency. Same thing with positron. The only difference is that these things ring out of phase, 180 degrees out of phase.
That couldn't possibly matter, because when things are moving towards each other, that phase would be constantly changing. So there'd be times when the phase would be exactly the same and phased out. So it just doesn't work. You can't have things in and out of phase when they're moving.
That's the only difference. So there's the vibration, there's the yin and yang in your theory, right? Yin.
I mean, it just isn't going to work. You can have them at a different frequency, and that's still not going to do it. There's always going to be distances that are perfect harmonics. So they'd always end up stopping. It's a harmonic, I can stop. Oh, it's a harmonic, I can stop. They're not going to be constructively interfering.
And yang. There's a vibration in your theory, which is the resonant frequency. Now, the thing is that when you have two frequencies come together and they are in phase, then those reinforce with great a very large area of high pressure. So therefore, if I get two blocks resonating,
again, it isn't a very high pressure. It's just the same pressure on a different slope. So instead of two 10 megahertz vibrations, you have one, of amplitude. How to measure amplitude? What's the word for amplitude? So you have two waves. One wave is only 5 volts, and and this one has a 5-volt wave, and the two hit each other constructively. Well, then you can create a 10-volt wave, all right? But it's still affecting two objects. So you haven't multiplied the wave, you just changed it. So now it's 10 volts, but it's on a different frequency. Because you've cut the frequency in half, essentially, by pushing the amplitude up here. So it was going 10s here, now it's 20s here. 20, 20. So you only get 5 20s, where before you had 10 10s. So you don't have more energy. So the fact that it says 10 volts doesn't mean it's more energy, because you have half the current, so to speak, to turn into an electrical analogy. So increasing the voltage when you're having the current, doubling the voltage while you have the current, won't do you any good.
yeah, exactly the
Same wattage.
same frequency. When their waves collide together, they make a region of high pressure, which pushes them apart. Okay, so the reason why there's a force there is because we have a high pressure area and a low pressure area on the outside. That is what causes them to repel.
Oh, Franklin,
Don't interrupt me, please. Let me finish my explanation. If you have two of the opposite, like a positron and electron, then their waves will cancel, creating an area of low pressure. Therefore, that attracts them. And this is a real physical reason for why attraction occurs. And there were people who did experiments 100 years ago.
Again, it just can't possibly make a difference. Like I say, the waves would be constantly constructively, then destructively interfering when they're coming towards each other. So waves coming towards each other would destructively interfere just as often as they constructively interfere. And so it would all balance out. They would do the 10 volt thing just as often as they do the 0 volt thing. So it would add up to 5 volts again.
Prove that this does in fact create attractive and repelling forces.
Anyway, you should watch some of Walter Lewin's. Oh man, you're just so. I really thought you had watched a couple of these videos. I mean, I've played Walter Lewin's fucking 802 lectures. I just talked the other day about playing all of them. All right, I'm making a whole video series where I point out how this is where their physics is shit. This is where their physics is shit. This is where their physics is shit. Ah, man. Anyway, I'd be interested to see what you agree or disagree with along the way. Well, again, so I've already suggested exactly the same thing, that I just play it and I just show you where they've assumed what's happening. They don't really know what's happening. They have no explanation for what the magnetic field is. And clearly, they don't even understand that there's no such thing as an electric field. So yes, it's on the table. It's a possibility that I will actually go through the tedious process of playing all his videos. Just to point out.
They had did experiments with pulsating balloons in water and showed that these kind of pulsations can create positive and negative things, right? So that's how this is.
So again, they really haven't done any of this. There's no way you can't analogize magnetism strength to these silly swirly things in a paint bucket and all this. Nowhere near an applicable attractive and repulsive force.
This is your I don't know, your entrainment where you're in Kepler, whatever you're talking about. But once you produce,
Ether is a universal quiet purring vibratory mechanism.
Quiet purring. Universal quiet purring vibratory mechanism. I mean, these people, this just ruins the whole dissident movement. You really do have to just screen out the wackos.
And it's very simple models. It doesn't have anything to do with quantum physics or Positrons
I'm just saying.
Well, you just said it had something to do with entanglement. Well, guess what? That's quantum physics, but whatever. I mean, it is now.
I mean, the thing is that all of that is incredibly vague. That your theory would be much improved if you just said that the quantum unit is in fact the electron.
Yes, but then you'd have to fit it to the evidence, which you don't even do. So again, Franklin, I mean, really, you're just saying that the whole universe is made out of electrons and protons, essentially, some whatever, positron, some third unit of a proton. And that somehow all this stuff is arranged and what? It's clumpier when it's atoms, or it's denser, and again, how are these things communicating? Are you saying that photons aren't a thing? You know, what are they? You think they're just vibrations in what? You don't have any ether. You say the protons and the neutrons are, I mean, the protons and the electrons are the ether. Where's the ether that allows them to communicate? How do they talk to each other?
Well, I'm not saying it isn't. The electrons are built up from elemental etherians.
And I'm saying that there's no evidence that the electron has ever been built out of anything. All the experimental evidence says that the electron is truly fundamental. I mean, I'm just trying to, because I'm trying to help your theory here, in that, like, what you said is right, except other than a super vague concept.
So again, just there's no real way to detect even if electrons were made of something, how exactly will we detect energies that small? Oh, that's right, impossible.
That, you know, that because if you say that the electron is made out of ether units, then you have to answer the question like how many and in what structure and blah 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 and all that. Versus if you said that your fundamental ether unit must be.
Why bother? I mean, I think just everybody ought to just say as a premise that anybody who wants to talk about a physics theory has to start from the atom and the forces. You know, you just have to start from the phenomenon of gravity, let's say. But I mean, there's no point in doing this. What is the fundamental or elemental bits made out of? Because you're not going to be, nobody can know that. So everybody's just talking out of their ass if they start saying, I know what kind of marshmallows protons are made out of. It's just bullshit.
Electron, then you don't have to answer any of those questions.
Well, origin, the point of my model, a lot of it is origin. And if you have all these,
Origin. So he's an origin guy. Origin. So he's really a God guy. So the whole thing really comes down to the ether made God, and then God made the particles, or some kind of crap like that.
Hundreds of electrons, where did they come from?
So how did you, because I answered that, I said, well, how does it matter? It doesn't matter, does it?
Well,
Exactly. So Franklin's right about this one. Let's just start with some elemental functioning bits, and who cares about trying to dissect where they came from? Let's just understand what they're doing. Yeah, that would be productive.
I don't understand a model where you have an elemental electron where you don't know how they came about or where they originated from.
Why would you?
Why would I care? Why would I care where mosquitoes came from? I would just care that mosquitoes exist, might bite me, might give me some disease. Why do I give a shit how long they've existed on Earth? What was the first animal they ever bit? You know, what kind of volume of? I don't care about any of that shit. It's irrelevant.
You need to know it. I mean, this is my point. I want you to try and answer this, which is we know electrons exist. You can build, if your theory is based on electrons, then does it? I mean, as long as you know they exist, then why does it matter where they come from? I mean,
Okay, so again, we know they exist, but clearly there's lots of lack of clarity about how they function, because I used to be of the impression that somehow electrons could be just floating around and they could be on the surface of something and just be free but barely attached, like static electricity or something, like little pieces of dust. There'd be a little extra electrons there and a little extra electrons over there. And I was totally wrong. That's just bullshit. There's no real evidence that ever happened ever, that there's any such thing as a free electron. They're all bound to something, and bound with energy in the sense that they're attached to a proton in the sense they're attracted to it, and they're repelled by other electrons. And there's no electron sitting in some kind of comfortable space saying, oh, everything's just fine here, no one's influencing me at all. No, they're all pressurized somewhere. They're all busy.
in a theory which states that electrons are in fact fundamental, then there is no answer to that question. That you know, basically they exist, and that's
Yes, they exist, and they existed forever and ever and ever and ever, and the universe just keeps bouncing them around, the force bits. So the force pressurizes them into atoms, and then as the pressure reduces, because all the pressure's inside the atoms start to fall apart, the pressure's released. Yeah.
what actually makes it fundamental. So how is it not knowing where the electron comes from? How is that a problem for anybody's theory?
I think origins are important. It can have a logical origin for something I think is right.
Well, it's insane. Okay, first you can't see it, and certainly the origin of the electron. You don't need a fucking god to make an electron. So what the fuck? This is all pretty stupid. Oh, the simplest thing in the universe, we have to explain the electron, but we don't have to explain the existence of the God who made him. Hell no. He's immune to requiring an explanation because he can just exist forever. And, you know, after sitting around forever, he can decide to make some electrons. All of a sudden, he decides with his free will, oh, my free will has realized I must make some human beings. Ooh, but I don't have any electrons to make them with, so I better make some electrons first. Ooh. I mean, these people are so fucking stupid. Oh, you have to have a creation story. Why? What do you think it's going to be? God all the way down. God made God, and double God made God, and triple God made God, and then quadruple God made God, and blah, 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 blah. Fuck you.
Well, the thing is that you can keep on going down this rat hole, you know, the rabbit hole, which is if you think the origin is important, then where is the origin of your theoretical fundamental unit? And you can still ask the exact same question. You have exactly the same problem. So I'm asking, so where did your ethereal unit come from?
The very first thing was a universal oscillation, which then...
Yeah, where did that come from? Where did the universal oscillation come from? Universal oscillation of nothing, of course. The universal oscillation without an oscillator. Where did that come from? Let's see if we can get him to admit. Well, God done it.
Converted to a universal ether. Vibratory ether, the oscillation converted to vibrations.
But that's illogical because in order to have a vibration, the only way that vibrations can be mediated is through a medium, a physical medium, without there being any physical.
Yeah, you can't have the sound before you have the speaker. You know, it's just a little bit illogical. Well, the sound came first, and that made the speaker. Huh? What?
Medium, no vibration is possible. So then you have to ask, well, where's the media for that vibration? You know, you keep on playing this game.
Well, you only need a medium for quantum systems. For original space, you had universal oscillations with tiny...
Universal oscillations with tiny God testicles.
Spaces in between the oscillating units. So
And how do you have
oscillatory motions and
I mean, how do you have an oscillating unit without anything to be oscillating?
well, original space was more self-compatible than space is now.
Self-compatible. He did that before. So he started the video with self-compatible. Now he's ending it with self-compatible. Complete gibberish. I mean, Ken Wheeler, oh, he's so envious right now. Ken Wheeler saying, oh, I wish I thought of that. Self-compatible. That's so cool. What a pile of jargon.
Now, since the ether, it's still with an ether now, and it's just not the same thing anymore. It is kind of a hypothetical, I admit that, but if you go from that hypothesis, you can go from there to everything else logically.
No, you can't. Not me. I mean, it's no logic at all. God, these people are so fucking insanely crazy. Shit. This planet is so scary. Hello, Gary. Giving your polarized force bits. Okay, good enough. And light photons. Okay, and electrons and protons. Well, force bits, we're in the first part of what you're saying, and now you're talking about matter bits. You got to separate them. So photons are force bits. Gravity is a force bit. Magnetism, the force, the magnetic field is made of force bits. Electrons and protons are matter bits, not moving the speed of light. The force bits are all little bits moving the speed of light. The matter bits, no. Keen to understand your definition of charge. Well, I've already gone over it. The last video has charge in the title, I believe. Charge is pressure in an atom. That's what charge is. And, no. Charge is the electron, and the proton are the origins of charge. They're the origins of magnetism. So what was I going to say? Oh yeah, so when something has a charge, all right, see, you got to understand the difference between the elemental things are called charges, which is a real dangerous thing, right? Because the difference in the charge between the electron and the proton is what's creating magnetism. The pressure between the electrons happens because a magnet compresses the electrons. Well, anyway, I went over all that. I went over all that in the beginning of this video even. But the last video, I have pictures of it all. So watch the last video. The first half hour of the last video explains charge and the difference between electricity and magnetism. I mean, charge is just a dangerous word because we call an electron a negatively charged element. We call the proton a positively charged element. And that's perfectly correct in the sense that the force affects the two things in an opposite way. So it makes perfectly good sense. But when we charge a surface, the charge on the surface is because the electrons and protons have been pressurized. That is, you pushed the electrons in and you pulled the protons out, and vice versa at the other end, where you pushed the protons in and you pulled the electrons out. So you created pressure. You pressurized these atoms by compressing the electrons, and you depressurize these atoms. That's a different thing, that kind of charge. Well, obviously, one object wouldn't have charge like a magnet. It wouldn't have plus and minus. It would have positive charge on one side and negative charge on the other side, obviously, because it's going to be what the electrons are going to do is all that matters for the conveyance of electricity. So the way we understand static charge is merely in seeing how it affects, how it's resolved electrically. And it's resolved electrically by moving electrons. Oh shit, I shouldn't have said moving electrons. Moving the pressure between the electrons. The electrons only move a little bit. They're just balancing pressure. Electrons that are under low pressure, electrons under high pressure, close together. When the two hit, this pressure moves into this system. And so they become equally pressurized. All right. Yeah. Well, anyway, I just refer to the last video. I really don't want to turn the thing on and do the same drawing as I did yesterday. It's just being too redundant. Not this morning's video, but yesterday's, right? What was this morning's video? Yeah, no, I don't think it was this morning's, actually. Well, anyway, it's the one titled Charge or something. It's all about pressure between electrons and orientation of atoms. So the position of atoms makes something magnetic. That is the position of the electron and proton in a group of atoms. That creates the magnetic filter. And the pressure between the electrons creates the electrical voltage potential. So it's pressure and position. pressure inside the atom of the electrons, position of the electrons and protons in the atom. The position creates magnetism, the pressure creates electric potential. But yeah, I wish they had a different word for surface charge and the charges that create it, because it's really not the same thing. The surface gets charged because the atoms are not only repositioned, but the electrons are pressurized or depressurized. So if it's a low voltage, they're depressurized, a negative voltage. If they're a positive voltage, then the electrons have been compressed or pressurized. So they're tighter together, more energy between them, so to speak. Yeah, that's the tricky part, right? Do we need the word charge? Well, you have to make the distinction between the magnetic monopoles. So you have to call that something. The difference between the electron and the proton, you have to call it something. So if you don't call it a charge difference, then you need a word for that difference. I mean, we're so used to the word charge and associating it with electricity, and we're not really used to associating it with magnetism. But clearly, like I said, the elements of charge, electrons and protons, are the very thing that are creating the magnetism. There's no magnetism without the two charges. So yeah, it's difficult. I have to think if I can come up with a simple, like a force bit versus matter bit, if I can come up with a way of saying it that, fixes this language duality problem, this dual use of the word. Yeah, that just doesn't say anything, right? Force bit polarization difference. Because once you get into polarization, right, now we're back to the fact that polarization of light is very different than magnetic polarization. So, that just gets dangerous. The word polarization is dangerous. It's been used like the word wave. It's been used to describe too many kinds of phenomenon, very different phenomenon. So that really won't work. I mean, they even use it for electricity, right? I mean, they use the word polarization to describe the plus side of the battery and the minus side of the battery, which is just, again, it's just not the right way to understand it. It's pressurization, So we need a word that goes with pressurization, pressure. We need terminology that implies that orientation creates magnetism, and it's the orientation of these two opposite elemental bits. So we have to have some way of saying electrons and protons are inverse, and then they get into antiparticles, right? So then we're really fucked, because that's just an idiotic way to look at it. They're each other's antiparticle. I mean, that's just retarded. Yeah, I got to come up with better language, because the word charge is just so dangerous. The surface charge is electrical. Atomic charge is magnetic. That's probably the way to say it, right? To understand it. Surface charges on materials are magnetism, primarily. Well, see, that isn't right. No, because the surface charges are voltage potentials. So yeah, forget it. I can't use that either. They're both. I mean, clearly something that's charged is both things. It's both magnetized and it has voltage potential. I mean, the balloon with the static charge sticks to the blackboard, right? I mean, it sticks because of magnetism. That's the force that's sticking it to the blackboard. And clearly, I can run electricity, a spark, off of its charge. So it's doing both, but it's doing both. Both are very different things. One of them is the position of the atoms on the surface of the balloon, and the other one is the pressure of the atoms. The differential in pressure between the balloon and the blackboard. Well, it's not even the differential. See, that's another way to say it, right? Because the balloon is actually turning the blackboard. It's magnetizing the surface of the blackboard. The atoms on the surface of the blackboard are being reciprocally magnetized in the sense of oriented. And that's why the balloon can stick to the surface of the blackboard. Because it's transferred the pressure. Let's see, you have a polarized force bit, black and red, that have different impacts on matter. Yeah, the forces inversely, there's positive and negative force, there's positive and negative matter bits. So that's the simple way to understand it. Those are the only things, those are the only players. Positive and negative force bits, positive and negative matter bits. That's it. The matter bits don't interact with the matter bits. The force bits don't interact with the force bits. The force bits hit the matter bits, and the matter bits can hit the force bits, but there's nothing else. There's no other interaction. Force bits move matter bits. And force bits are filtered, quote unquote, by matter bits. Yeah, it's just language is so broken. I mean, you really can't use the word wave in any rational way anymore because they have waves that are going in straight lines, just like a torpedo, calling it a wave. Just, it's all broken. Can magnetism, charge, and electric phenomena all be boiled down to polarized force bits interacting with, why are you doing this, A matter bits? There's no A matter. If that's what it says. I don't even know what it says. It says A mirror. A mirror with A mirror bits. I don't know what A mirror bits are. Again, electric is just pressure. Charge is orientation and pressure. And magnetism is orientation. Ah, okay. I guess I could have figured out the A just goes after the M, but I wasn't sure. Well, if you're going to say the force bits are polarized, you sort of have to say the matter bits are polarized. I'm just saying that. So that would be the only correction I make. Boiled down to polarized force bits interacting with polarized matter bits. You could say charged force bits interacting with charged matter bits. You could say, positive and negative. But again, see, the positive and negative is dangerous just because there's no real negative. There's just less pressure and more pressure. So There's no negative electricity. There's just low potential and high potential, high pressure, low pressure. And the neutral is arbitrary, the ground. I have a point about the inverse square law, spherical admissions and gravity. I don't know what you mean by a point, but you mean a helpful reinterpretation of what I've said, or I just, you can just attempt to dispute it. I'm just saying the inverse square law is clearly the byproduct of spherical admission of radial force, straight line force. Straight line force radiating from a half sphere creates the inverse square law. Well, good. I'm glad I don't know if you totally get it, because people have said they totally get something without totally getting it. But it's good to hear anyway. It sounds like a promising sentence. So what's your point? I have a point about the inverse square law. What is it? Type that one. Oh, put up my jargon. Yeah, put up my jargon. Very different than Ken Wheeler's jargon. I'm sure you'll agree that this jargon is very, very different than Ken Wheeler jargon. Very, very different. All right, regarding inverse square law, my understanding is that it's based upon the 4x pi times r squared formula. Yeah, well, the pi part is only coming in because that's how you dictate the circumference of the circle, the sphere. So that's just accounting for the fact that it's like in Maxwell's descriptions of magnetism and the force lines. How many you draw is entirely arbitrary. Okay, the point is all you're really trying to measure is their degree of divergence, their percentage of divergence. And clearly, when you're drawing it in 2 dimensions, you have to account for the 4-dimensional effect. So when you draw it in 2 dimensions, you're actually drawing it twice as much as it actually is in that dimension, because you're accounting for the fact you can't draw it this way. Okay, so it's separating in 2 directions. So the 2 things are like separating this way. Okay, in 3 dimensions, they can go in both ways. So that's what you have to understand. It's this square, the square from corner to corner, not the square from side to side, or the rectangle from this way to this way. It's the corner to corner square. So that's why the divergence is the inverse square, because the square, okay, is when you double a square, that is, multiply it, you create 4 squares. This square at this distance 4 times fits inside. So it's 4 times as big an area at half the distance. Okay, my understanding is that the spherical admission formula is based upon emission from a single location. Again, you're not getting it. It's a single location where it's radiating in all. See, it can't radiate backwards, right? You do understand they can't count the force that's going the opposite way. They can only count the force that's heading in the direction they're measuring a field in. So they're just point sourcing it, which means they're just saying it's radiating from this little ball, but it's still a little ball. It's still a round surface, so to speak, and it's radiating in every vector possible from that round ball. So it's exactly the same as looking at it as a big sphere as looking at it as a small sphere. It's the same thing. You haven't changed how it radiates the force. Like if I made the sun smaller, I don't change the fact that it's radiating the force as a sphere, not radiating the force as like a magnet. Like off this sphere, it's going straight out, and over here, it's going this way. It's not broken into kind of strength fields. It's equal in all directions across the surface of the sphere. I mean, it's just not that complicated. Like I say, you could just do it mechanically. Just think about it. That if I'm making this square, okay, if I increase it the same amount in both directions as I move it, that I'm clearly going to create twice as much area. I mean, if you just think of it, like I said, Maxwell, I think the ray thing works. I mean, just the divergence of the rays. If you just understand it that way, that when I'm close, I'm likely to get hit by a lot of lines. And the further away I go, the less likely I am to get hit by a line because they're so far apart. I mean, it's just that's the inverse square law. All right, anyway, of course, it is radiating in all directions. Agreed. So again, that's the point. That's what creates the inverse square law, is you have to radiate the force evenly over 2 dimensions, which is a sphere. It's spherical. The admissions are spherical. Agreed. For gravity, the radiation is from all locations on the surface of the sphere. Thank you. Not from the center. Well, it doesn't matter whether it was from the center, because the center would still be a sphere. But anyway, just, I don't know. It's just, I don't know, semantics, but it's like I said, it doesn't matter how big something is. I put anything into the universe, you could sort of understand if the gravity was light and it's an equal amount is coming from all directions, that it just doesn't matter. It's no matter how big or small the thing is, it's going to be hit by the same amount of stuff from all the vectors. And the admission of force is exactly the same phenomenon. It's admitted randomly in all directions, unless there's some reason it's being aimed like a laser beam or something. Let's see. I just don't know why you're doing this. 4 pi times r squared formula does not apply to a square, as in gravity, a sphere, as in gravity. I just don't understand how that's not true. So you can say that's not true, but I'm just saying the 4 times pi times r squared formula. Well, I don't know what the 4 pi r squared thing is. So I don't know what that's the formula for velocity, which is a completely different formula. And the formula should be 2 times pi times r squared. So I don't know what formula I don't know what that formula is, but it's not the formula that creates the inverse square law. Obviously, the r squared is the r. R squared is a different than just r. So you're dividing by r squared rather than just r. R would be 1 dimension, just this way. R squared, both directions, this way and this way. So that's the difference. R squared is just conceding 2 dimensions. The square is just the concession to two dimensions. Up, down, left, right. Can't do backwards. Please bear with me. Well, I'm trying, but I'm just saying. This might be useful to you. The 4 pi r squared formula, so again, I just don't know why you're doing that, is the formula for spherical admissions. Well, where? Show me where the r squared needs 4 pi. The 4 pi is superfluous. It's 4 pi of what? For what purpose is the 4 pi? The r squared divided into anything is already accounted for spherical admission. That's why it's called the inverse square law. It's not called the 4 pi inverse square law. Newton's equation doesn't have any 4 pi in it. It just has mass over r squared. Yeah, well, obviously light diminishes exactly like gravity diminishes. So my hand, 4 times bigger here than it is at half the distance. So here, that big, half the distance, only that big. Clearly, 4 times smaller. Okay, the hand was this big here, and now the hand's only this big. Same thing. But I don't know what I need the 4 pi for. So I'm saying the 4 pi part, like I said, in Einstein's equation of bending light, he uses a 4 pi instead of a 2 pi. Okay, so the traditional, but the pi is usually times velocity. But so I don't get this. I don't know what the 4 pi is for. I don't know what the 2 pi is for. I don't know what formula like I said, I know Newton's formula. Newton's formula doesn't have a 4 pi in it. As you know, matter emits photons. Well, it reflects them mostly, but okay, matter can emit them. Atoms can. So both objects in gravity scenario are bombarding each other with photons. Well, photons are irrelevant to gravity. So it's such a tiny amount of energy by comparison. The amount of gravity is insanely more dense than the amount of photons. Photons are a tiny percentage of the radiation in the universe. Point about gravity is the little subtle point to recognize is that when you're getting affected by a force, what happens to the force after it leaves you is totally irrelevant to you. Okay, whether it's hit something, it doesn't hit something, you'll never know. So the only part that really matters is the part that hits you. When it leaves, it's irrelevant. It doesn't matter anymore. Can't affect you. It can affect other things, though. So that's the point of gravity, is the stuff that's affecting you is coming from something else. I don't know if that says it as well as I want to say it, but I've already done the analogy. I'm being pulled towards the center of the earth because the other side of the earth is absorbing, pushing. It's stopping energy from getting to me. It's stopping it because it's slowing down to move a bunch of matter towards me. And by moving that matter towards me, a bunch of force didn't hit me. And therefore, the force above me is stronger than the force below me. And when I do it, when I'm doing the same thing, that gravity that left me doesn't matter. Doesn't matter if it hit a steel plate and bounced right back. I'll never know. Bombarding each other with photons. All right, let's see. 4 pi r squared is the surface area of a sphere. And again, obviously, when you're measuring a force forward, you don't do the surface area of the sphere. So there's no 4 pi is irrelevant to measuring this divergence. This divergence only happens in 2 dimensions. When the force is emanating, it's only emanating in 2 dimensions. Its strength is only affected by 2 dimensions. It's not affected by the entire sphere. I mean, the relationship between, look, I guess what we're just arguing over is you're just saying, look, there's a relationship between the radius of a sphere and its circumference. Yes, I understand that. That doesn't have anything to do with this. Okay, the radius is relevant to a lot of things. Its relevance to the strength of force emitted from spherical radiation isn't the same formula. Yes, you can have different formulas that use r and use r squared, and they're doing it for different purposes. If your purpose is to measure the circumference of the Earth, okay, I get it. Okay, fine. That's not the purpose of explaining the inverse square law. There is more to gravity, says you, than the incoming force bit. Sorry, that's all there is. Pushing both objects together. But again, it's not really pushing. I made it as clear as I can. It's the absorption of the force that is the key point. The conversion of something moving the speed of light. See, the force is moving the speed of light. It hits an electron. The electron doesn't move the speed of light, much lower. So the force is being incredibly delayed in its progress. It's not getting where it would have gone, because it's being slowed down, pushing a bunch of electrons. So it's doing this to electrons instead of being way over here. So that's not exactly a push. But yes, it's pushing. But I'm just saying, it's not exactly a push. Both objects are also pushing each other the other way. So again, no, the other way is irrelevant. I can't feel the other way. Let's see how to say this. You can't undo the absence of the force. There won't be any place where you're getting extra force to replace it in the opposite direction. There is nothing down there where they're absorbing the force coming at me. So they're slowing the force down by moving towards my feet. So the force is being delayed. There's no other force coming this way to compensate for that. There's just the normal amount of force. So where's the compensation? They absorbed some force. Now the force isn't hitting me. They absorbed it. They ate it. It doesn't get to me. How is there anything else that's going to push this to compensate for the fact that this pressure is higher? There was 10 and 10 out here. This thing stopped some of it. So now there's only 9 going this way. So there's a 10 and a 9 here. And I'm here. There's no other force making this a 10. It's still a 9. It's stuck being a 9. It's a 9. It's going to stay a 9. And I'm going to move into the 9. I'm going to go from high pressure to low pressure. No, I don't know. Let's see what he's saying here. Both objects are also pushing each other way. No, that's not happening. With emitted and reflected photons, the reflected are irrelevant. They'd be equal out. The emitted would be irrelevant. They're equaled out. The only one we're looking at, it starts out with 10 and 10 out here. This thing moving, absorbed some of the force going this way. There's now only 9 here, and there's 10 out here, and I'm in that differential. And therefore, I'm going to move towards the 9. And when I move towards the 9, I've moved, which means to move, I had to absorb some of the 10 force. And now I've turned the 10 force into a 9 force. And now this thing is going to have 9 over here and 10 out here. And it's going to move in. You get it? The sun emits photons spherically in all directions, not just in 2 dimensions. Again, you don't measure it that way. You can't possibly, as an object, feel the light going the opposite direction. Can you ever feel the radiation that the sun is radiating in the wrong direction? God damn. Sorry, but that's just, you're just being obnoxious here. Thank you, Mansour Smith. I don't know what that means, but I don't like it. My point is, I don't know if you got a point, is aiming towards showing that push gravity is a combination of incoming force bits pushing objects. Again, it's not pushing. The fucking force is absorbed. It's used. When you use something, it can't do something else. If I'm using this cup to hold coffee, then it can't hold Jell-O. The coffee can't be someplace else. If the coffee is in the cup, the coffee can't be over there where it was going. An outgoing force pushing the objects away. Well, like obviously it's not a yin-yang because obviously the fucking earth moves into the sun. Obviously gravity works. So you're saying my point is I'm going to use a combination gravity that couldn't possibly create gravity. Well, go for it. I think your gravity will fail. I mean, they're just see. So he said before, I get it, but you don't really get it. If you move a matter bit, you've used energy. Just a fact, because the force bits are always moving the speed of light, and the matter bit won't be. So you're consuming the force in the sense that the force will not get where it was going. Until you reach equilibrium. But again, equilibrium is just it's another disguise, because it still means the stuff goes in and stuff is going out. But it's always disproportional in the sense there always has to be accounting for the deficit, the stuff that created the opportunity for equilibrium. So you're still using it. The current stuff is being used. The money you're putting into the bank is the money going out of the bank, so to speak. The last money in is first money out. So equilibrium doesn't really mean anything. I just don't know how this sentence, I mean, this paragraph could mean anything. You know, in the sense that if the incoming force was pushing them towards each other, and then some other force was pushing them away, how you could possibly have movement. I already gave you something to imagine, and apparently you can't imagine it. I mean, I illustrated it. Now, what's your response? You have 10 here and 10 here. This thing moves. That means it absorbed force. It occupied it. It's not getting here anymore. So you have to admit that here is not 10 anymore, because this stopped the 10 from getting there by absorbing. So you will admit that this has to be 9. This is still 10 out here. This is 9 here. I'm in between those two things. Which way do you think I'm going to go? I mean, there's no rational response that you can say that's somehow wrong. It's impossible to argue with. It's perfectly clear. Imagine two very small suns, both emitting heaps of photons. So again, this photon thing, photons are such a tiny amount of energy. You know how much energy it takes to move something with photons? How much energy do you think it would take? Actually, photons hitting this. You know how insanely powerful the laser beam would have to be to move this the same way gravity's moving it down? Okay, meaning heaps of photons. My point is that gravity might cause them to move apart. So again, he's calling photons gravity, which they aren't, as the repulsion exceeds normal gravitational pulling towards. So again, you just have no conception of exactly how weak photons are by comparison to gravity. How insignificant, tiny percentage of the energy in the universe is in the form of energy at a frequency. Minuscule compared to the density of gravity. Magnetism is 10 times 10 to the 42 times more powerful. That's the percentage difference between light and gravity. Is the same number. It's a huge number. There is no 1 and 2 in opposition. So again, this is just nonsense. The photons have no power against the gravity. Zero. Zero. There is zero force by comparison. Zero. They're so insignificantly tiny by comparison. Puny influence. And especially at our distance from the frickin' sun. It's an insanely weak force. Well, there's no point in doing that. I'm using the word photon to represent both force bits and frequency photons. It doesn't matter because you're including one thing, one kind of radiation, and saying it's significant when it's not. The light coming from the sun is irrelevant to the gravity equation. It has no meaning. You can't move a frickin' asteroid with the light coming off the sun. Ugh. No point. I guess, you know, if this is the sun and it's absorbing energy in this direction, so it's going to constantly move back and forth all around because it's being pressurized from all directions. All right. Now, I put an object over here. So I have to get the movement thing happening. And, you know, it's always inductive. Let's see how to best describe it. The amount of energy that the sun is absorbing to create the pressure inside the sun. Do you understand that the pressure inside the sun is being caused by gravity? That it's not being caused by anything other magic stuff. It's being caused by gravity pushing the atoms into each other. Like water above your head, like water pressure. The deeper you down you go, the more and more pressure it creates. That's all gravity. That's when you go down deep in water, you're feeling what gravity does when it goes through atoms. It creates more and more and more and more pressure. That pressure is 1 trillion times, okay, more energy than all the radial light coming off the sun. So you have to understand the idea that the sun's radiating force is wrong. The sun's absorbing force in huge amounts to create the pressure that's making atoms. No worries, Gary. I'm sorry. It's just plenty to worry about. Yeah, sorry. Plenty. Just offering some ideas to your theory. Well, I don't know how off this notion that, again, this simple explanation, this solves it. The force is equal, 10 and 10. I put something in there. This thing moves. It had to absorb force to move. It didn't move on its own. It moved because the force pushes it. The force pushes it, it moves. It absorbed force. That means there's only 9 force bits here now. 10 force bits, 9 force bits. Which way do I move? Yeah, I move towards the 9. Just offering some ideas to your theory. Keep up the good work. Yes, well, I'll keep working at it, but I'm just saying, see, I'm just saying, you said, I get it, and then you basically said, no, I don't get it, because, you know, you complicated it with a scenario that really doesn't have anything to do with, you know, how gravity's working. But it's okay. Something's better than nothing, so I'll take what I can get. At least it's on the subject of physics. You didn't mention my hair, so super. We're way ahead. I don't know whether McCule CS is being sarcastic. See, it's just this medium just sucks. It's perfect already. Yeah, you're just being sarcastic, right? I think it is quite good, actually. I wouldn't claim it's perfect, but I mean it's very lucid, in my opinion. There are no flying alligators in here. There's no bullshit. These are really clear words I'm using. I'm not using any funny language. Yeah. There's no counter space. Yeah. But it is dismal. I mean, this is the most depressing thing. I don't know how it's not just killing me. It's just so bad. You know, 7 years of work, and I just can't get anybody to say, "Oh, I get it. Yeah, it's so much better. It's so clear now." Gee, we got rid of all that messy, sloppy extra fields and all that, loop-de-doo nonsense, all this wavy crap. I mean, it's just so simple. Oh dear, conspiracies. Look, there was conspiracies like, okay, Roosevelt was, had some really bad years. So where, he could have died because of his polio. And they didn't show the public that because it's the Depression, war, all kinds of shit. And it's not going to make people feel very good. So there was a conspiracy not to let the public know that the president might be dying. Yeah. Fine. Conspiracy. Obviously, there's been reconstructions of history where people have attempted to hide something from the public. Yeah. There are conspiracies that involve 5 people, 10 people. Yeah. Do I believe in any conspiracies that involve more than, let's say, 15 people? No. Because one of them's going to the National Enquirer for big bucks. I mean, it's just inevitable. It's like if you paid women to keep quiet about you sleeping with them, you kind of know that you might be able to get away with it 1 or 2 times, but when there's a certain number, you're going to get fucked, right? Once you go over a certain number, the odds of you being outed go way up. So it's just laws of averages. So you just kind of know conspiracies can't have many players. Because the more players you got, the more likely it is you're going to get outed. So it's just that obvious. There's a strict correlation between the number of participants and the likelihood of a outer, somebody who spills the beans. I'm just sorry. I don't even know why you would even think the rubbish evidence of fake moon landing has any hope at all. I mean, it's so frickin' silly and it's so easily debunked that I just don't know why you would even fall for it. It's so bad. I mean, reflections in glass windows, obviously in space where the sun is a little bright ball. I mean, just so many of them are just so stupid. I mean, the one where, they're on the moon's surface and there's a reflection in the guy's helmet and the other guy looks like he's not wearing his backpack. And it's just because the reflection is in a round surface. And so it's compressed the guy so much this way that you can't see he's got a pack on, but he's got a whole big pack on. He's just been compressed and you don't see the pack because of the compression. I mean, these are simple things. I mean, it just, I have such contempt for the human race, but the idea that you think all these people who worked on this stuff were liars for no reason. I mean, like not for some good cause, they weren't lying for Jesus or something. They're just covering up a moon landing. I mean, are you serious? You think all of these people would involve themselves in this? I mean, my father worked for a company that made the rocket engines. I mean, do you really think all of those men, all those people were just fakers and frauds? I mean, it's just so stupid. Well, you bringing them up only enhances their popularity, to tell you the truth. You're only doing the truth or nuts a favor by talking about them. That's exactly what they want. So, Mansoor Smith, I guess you apparently just want to get blocked, right? It's just that you're just saying, please block me. What about ancient alien? God damn. JFK was actually assassinated on my birthday, so it is actually a subject I know an awful lot about. And there's just nothing. The minimum is that Yeah, I think he was his brain. Okay, what was left of it didn't get buried with him. But other than that, this is all just rubbish. All right, look, anyone who brings up a truth or pile of shit. See, this is the danger of it. You bring it up and everybody starts talking about it. Anybody brings it up, I'm blocking you. So any more comments on conspiracy theory nonsense, I'm just blocking you. I mean, you can watch the fucking Zapruder tape. You can see it happening. I mean, it's just so fucking stupid. Fuck. I mean, yeah, it's just... Oh, yeah, that 9mm blew the president's head to Florida. Sure it did. A guy in the bushes with a 9mm, a 22. Yeah, he shot him with a 22 from the bushes. It blew his whole fucking head to Florida. He obviously was shot with an elephant gun. Well, that was a depressing episode. You know, just always just talk physics. End up talking about Sasquatch. I mean, just human beings suck. What about group video chats? For what purpose? Group conversations are idiotic. It's just a way of never staying on a subject. So if you never want to stay on a subject, yes, have a group conversation, because you'll never stay on a subject. I will talk to anyone who wishes to have a one-on-one conversation, maybe even 3 people, but you can't go over 3. 3 is the end. Anything over 3, you're done. The conversation is fucked. It will be fruitless and pointless. Yes, well, where have I discouraged something better than this crappy chat window? Haven't I almost said in every video, if you know anything about physics and can manage to speak some kind of English, yes, please, I'll let you in this room. All you need to have is a working fucking mic and be able to speak some kind of English, you know, and have something rational to say on the subject of physics. So email me at ds@draftphysics.com if you think you can manage it. And why would I do this hangout with whatever Brett Leave is? If that's Keen, and why the fuck would I go near that pile of crap? Fake Sagan is irrelevant, is crazy, you know, and also, you know, perhaps mortally wounded. And Tommy's a nice guy, but yeah, me and Tommy can talk for 5 minutes and then we're about done. I mean, what is there to talk to Brett Keane about? It's like, well, Brett, who do you think has told more lies, you or Donald Trump? You know. Well, whatever. You're wanting for the old days. The old days were fucking goofball, childish antics. So I'm not too interested. So you're really not making valuable contributions here. You're just like wishing to have just some sort of buffoon show. I'm trying to do serious physics. I'm trying to talk about how the physical universe works. I'm really not trying to have a fucking entertaining show or, I mean, yes, physics should be at least compelling and interesting, but I want the physics to be compelling and interesting. I don't want it to be whatever you're looking for. It's not the hanky-panky show. Maybe you can get Piro to do a silly room. He likes doing silly things. That thing is leaking. Yeah, drinking nicotine. Yuck. Back to old reliable. Ah, love that vape. Who's your favorite physicist? Oh, shit. I obviously don't like any of them because they're all full of shit. But I mean, to watch, I liked Professor Lewin because he demonstrated things. So demonstrations were nice to see. So I got to say, I like that as part of the learning process. Feynman was interesting to watch. So, I like Feynman. I like the way he tried to explain things. It seemed kind of honest, even though he's full of shit too. But the rest, I hate Susskind. I mean, he's just such a obtuse and full of shitter. Like I said, I like the Yale guy okay-ish, but all the talking head physicists, I hate them all with a passion. They're all rubbish. They're all nuts, is what they are. Nuts are trivial. Like Degrassi Tyson is just too generic. He's like lowest common denominator physics. He's like Barney the dinosaur of physics. And all the other idiots all have some wacky theory, either, Kaku and his silly string theory, the green guy, I can't remember what his thing. I think he was a string too, or another stringer. The other guy, Lewin or whatever, the Lawrence Krauss, some kind of dopey universe, the nothing made the nothing verse or some, bullshit, just, way out there, crack shit. And the other one's fields or everything, when, as I've just pointed out pretty clearly, there's only pretty much two fields, gravity and magnetism, and they're really the same forces filling the field. I mean, I've just acquired more and more contempt for physics as I've put together more and more of this. I didn't realize how many mistakes they have made. I mean, they have made so many wrong assumptions. It's like I've said it before, but it's like every time they could identify something, they did it wrong. Plus, minus, got it wrong. Push, pull, got it wrong. Wave, particle, got it wrong. They just keep getting every answer wrong. I mean, you can't be wrong that many times by accident, because that's why I'm feeling that it's just a religion. They want to make it silly and stupid. They're doing it on purpose. You can't be wrong that often by accident. Okay, participation is kind of running thin, so unless somebody shows up to say something physicsy, I guess we're done. I could just go through my little list here again. Electrons and protons are the monopoles of magnetism. According to Professor Lewin, I should get a Nobel Prize for discovering that, among my many millions of them that I should get. Yeah. Electricity is the transfer of charge pressure. I should just say some other kind of electron pressure. It's just really about the electrons. So yeah, I should just get rid of charge, because that ain't right. Charged objects have polarized or decompressed atoms. Have pressurized or depressurized, right? So they're either high pressure or low pressure. How the hell did I get depressurized wrong here? Spelled it wrong or something? I don't know why it's saying it's wrong, but not more or less electrons, right? So it's not about the number of electrons, it's about how close they are being forced, how much space they're being forced to occupy. If they have to occupy less space, they are of a higher voltage. Electricity is not movement of electrons from one atom to another or place to another. The electrons are just exchanging. When the atoms connect for a moment, the electron pushes the other electron but with its force. So if one of them's highly pressurized, the more pressurized electron pushes the other less pressurized electron further, right? The higher pressured electron wins. So when the two meet, the higher pressured one wins the battle, and now the pressure is equalized between the two. So when the two atoms leave each other, they now leave with the same pressure. So the high pressure electron pushes the low pressure one, and then the two separate with equal pressure. Ooh, that's good stuff. Ooh, really good. All right, charge is not an amount of electrons. It's simple. Said that already, but I'll say it again. Electrons just pass pressure in the form of force bits. So again, the force bits are what's between the paddles. So if an electron's under pressure, it's because there's another set of paddles here. They're pushing, creating the pressure. So this set of paddles moves into this set of paddles, and the stronger pressured one will push the other one, and the two will end up equaling out. There are no free electrons, right? Just a urban legend. It just doesn't happen. You have to make one that is loose. You can have a loose electron, but it's never free. It's going someplace quickly. All right. In the micro universe, measurement is an act of violence. I love that. The only fields are fields of force. I mean, that's a great quote. I mean, if Tesla had said that, or Einstein, or something, people would be like, "Oh shit, that was so bright and smart." Good stuff. And still no comment, though. Okay, so we'll give up. Well, it's 3 in the morning. It's probably time to give up. Probably time. All right, anyway, thank you for the participation. Every little bit helps to some extent, except for the off-topic stuff that just depresses me. But other than that, thank you. And such. Let's have a few more of me. See a delay. See? Delay. Force is delayed. Can't get where it's going. That creates an imbalance. Yeah. All right. Till next time, such.